So now, on the board to the left, the transistor I have is a 2N3904. The bottom pin is the emitter, the middle pin is the base, and the top pin up there is the collector. It is wired to be off. We have 5 volts and it's off. So this is how it's wired up. That's how it's supposed to be wired up. Now it's an NPN bipolar junction transistor, so the collector and the emitter are both N-type materials. So technically it can work backwards as well, but unfortunately the emitter is weaker than the collector. So we have 5 volts and it's off. I'm going to pluck the NPN bipolar junction transistor and turn it around. So now the emitter is on top right there and it's still off. You know, we have it wired to always stay off. I'm going to dim the lamp because not sure exactly when it's going to start lighting up. But yeah, there you can see 12 volts. We got the LED lit up. It's wired to be off though, the transistor. And therefore I'm going to turn it around because it was backwards. That's why it was lit up. It should be off at that voltage. It should be off up to, I believe, like 30 volts or so. There you can see we got 12. And again, I can raise the voltage this high because it's wired to be off. This would be too much voltage for it to be on. So just be aware of that. But in any case, there you can see it stayed off even though we raised the voltage that much because we have the emitter to base and the collector to positive supply. You have to make sure that you wire it in the proper direction. So now, there's more to this diagram than I was showing. So we're going to stick with the all my NPN bipolar junction transistors I came across, PNP as well. If they start with 2N, then the emitter is on the left, base is in the middle, collector is on the right. That's if they're bipolar junction transistors and they start with 2N. There's other components that start with 2N. But in any case, that's the pin layout. There's other transistors where the pin layout could be differently. So that would be a harder circuit to test. You can't just flip it around because the components don't line up as good. But in any case, again, it's NPN right there. So you would think putting in backwards would work the same. So I didn't illustrate it here. I probably should have. But the collector side, so we'll declare that this is collector. The N-type material is actually a lot thicker than it is on the emitter side right there. So the emitter will break down. A lower voltage, it will start conducting. So when you're looking at the data sheet and you see these numbers right here, what this is saying is the collector to emitter right there, when you want the transistor to be off, will build up about 40 volts across it before it starts breaking down. Now, the collector to base right there, as you can see, collector to base, it can stop an even higher voltage right there. So that's where it's going to fail in this direction when you put it in the right way. Now we got the third number down there. You can see it's lower. So as I said before, the emitter is weaker. So you get the emitter where it's more positive and the base is more negative right there. Because remember, you need a voltage difference. Then you can see emitter base open circuit. That means it wants to be off. But at about 6 volts right there, you're going to start getting some current flowing. And so even though it's flowing in the direction you didn't want to, that still basically turns the transistor on. So you get a little bit of current flow because we do have a resistor limiting current. LED is also dropping some voltage. That's going to add some voltage to this. And this is probably like worst case scenario, getting about 6 volts across the emitter to base before it starts conducting. Hopefully it's higher. So in any case, that's testing you can do or whatever. And you can read how they did their testing and whatnot. So again, you're probably not going to mix up the pins for the C945 in the same way. Of course, you can always mess up the pins. But for the 2N3904, you can wire all the circuitry right, put the transistor in backwards, and not realize it at lower voltages. But you raise the voltage, and then you will start getting problems. So I wrote this. Again, the collector side, technically you got thicker material. Sometimes you see that, sometimes you don't. The emitter, it's thinner. That's why it breaks down at lower voltages. But yeah, you get the P-type material more positive, N-type more negative. So positive, negative there. Then it's made to conduct that way. But if the P-type material is more negative, N-type material is more positive, that should keep it off. But again, the emitter side remember that's like thin material, it breaks down at a relatively low voltage, whereas it wouldn't break down until a quite high voltage the other direction. So, in any case, that's really about it. I can't think of any better way I could explain that other than if I could animate like really well or something. Hope probably other people made videos of that if this is confusing. So, in any case, that's it. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen and check out links down below. They all help out a lot. I'll see you in the next video.